Assalamualaikum and salam sejahtera. My name is Shamina Binti Azman with my team member Shawarina Binti Zainal Abidin. Today, I would like to present innovation product with the title Effectiveness of Ground Granulated Blast Furnace Slag GGBS with glass powder and fly ash as partial replacement of cement for strength in concrete. So, let me continue with my introduction and also problem statement. Nowadays, development of a nation not only depend upon the technology but also depend upon infrastructure such as school, shopping mall, bus stop and skyscraper. Infrastructure without concrete is not possible. Thus, concrete is a main material in every construction. The usage of concrete has been increasingly steadily from 2008 until now. One of the major elements of concrete is cement. Apparently, cement consumption grew by 3% year-on-year to 100 metric ton in 2018 from 97.4 metric ton in 2017, according to estimate from the United States Geological Survey. Apparently, concrete industry is now recognized as the largest consumer of natural resources and significant producer of waste. In the meantime, by previous study, Danaraj Mohan Patel give a statement that many researchers nowadays are ongoing into use of Portland cement replacement using many waste material and industrial byproduct. For example, pulverized fly ash and ground granulated blast furnace slag, as well as a glass powder as a binder with a partial replacement of cement, which takes some part of reaction at the time of hydration and also act as filler material. A part of the OPC problem, which is ordinary Portland cement, the production of glass bottle in Malaysia also a big problem. The glass bottle manufacturer in Malaysia produce about 600 tons of new bottle daily, but only 10% of this bottle will eventually be recycled by the factories and be reused to make a new one. And glass is the least recycled discard material. So, objective for the innovation of this product is first to determine the most suitable combination as well as effectiveness of concrete mixture by using GGBS, fly ash and glass powder as additive in cement. Second objective is to identify the workability, strength and water absorption in concrete after combination with ratio concrete 1:2:4 for grade M20. And the third objective is to demonstrate the material could be achieved high concrete compared with the conventional concrete. The methodology of the innovation start with the material collectors such as GGBS, fly ash, glass powder, coarse aggregate and ordinary Portland cement or PC. The concrete mix in the with ratio 1:2:4 with cement, sand and aggregate, which is grade M20. The fresh concrete was poured into the mold inside, which is suitable for the compression test. The use percentage was 20% replacement of cement and 48 cubes were being produced. The concrete was curing for 3, 7 and 38 days to find strength of concrete. This is the A group concrete from sample A to sample G, including standard concrete, were prepared in the laboratory. Samples were prepared accordingly to mix proportion and replacing cement with GGBS, fly ash and glass powder in different proportion. So for the testing, the test was held in concrete work laboratory at Polytechnic Sultan Idris Shah and also at JKR Sabak Benam. The concrete was curing for 3, 7 and 28 days to find the strength of concrete. So the type of testing include 3 testing, which is the first is slump test, the second is compression strength test, and the third is water absorption test. This is data for the slump test result. All the sample for the slump test were between 8.7 to 9.5 cm. That means it has medium workability and have true slump with the concrete subside maintaining its general form. From the graph show the sample D, which contain GGBS and glass powder together, does not collapse easily. This is because the GGBS and glass powder has excellent bonding with concrete mixture. From the result of the slump test, the workability of the concrete depends on type waste material as partial replacement for cement. 30% of cement replacement, where 10% of it contain GGBS and another 10% contain glass powder, have good workability. This is the result for the water absorption test. According to the data for water absorption test, all the sample A to G have water absorption in range 2.29% to 2.93%. The percentage of water absorption is less than 5% in standard concrete. It can be concluded sample replacement with GGBS, fly ash and glass powder can absorb water in small amount, especially with GGBS sample. This table shows the compression test of the sample of GGBS, fly ash and glass powder. From the result in the graph, according to the data, sample D, which consists 10% of GGBS and 10% of glass powder, have the ability to replace the cement better than another combination because it has achieved compressive strength 29.6 Newton per mm square for curing 28 days and 90.78 Newton per mm square compressive strength for curing 7 days. Thus, GGBS and glass powder together replace cement in concrete is suitable. As a conclusion, sample D, which consists 10% of GGBS and 10% of glass powder, is the best sample in order to replace cement in concrete. From the analysis, the value of slump test is 94 mm, compressive strength for 28 days is 29.67 Newton per mm square, and water absorption is 2.77%, which is fulfill MS26 and relevant part of BS 181. Thus, recycle of waste by transforming material into a useful content or product which can help to reduce environmental pollution, reduce the need to consume natural resources, and will not only get rid of dumping, but also decrease of carbon dioxide emission to atmosphere by bringing down the cement production. The impact from this innovation, firstly, is the replacement concrete by using GGBS, fly ash and glass powder will have positive impact, such as reduction of usage and production cement in construction industry, which is cement industry is the one main procedure of carbon dioxide and resulting to greenhouse gases. Second is production cement is from 50% chemical process and 40% chemical process from burning fuel. Then, reduction of dumping waste material, GGBS and fly ash and glass can produce other material in concrete, producing waste material into more valuable material and alternative raw material in cement industry. This innovation has received recognition and award in National Invention and Innovation Conference Exhibition and Robot Sumo Competition in 2018. This is the achievement in NISA. So that's all from me. Thank you.